Hey guys, Widgets World here. It is July 1st, 2020. Half the year's gone and we're ready to go. Up in smoke, like they say, right? We're just going to go ahead and jump into it, guys. We're going to start here with a few comments left from the previous video. And then we'll head on. We got the Schumann thing to talk about because we're still getting those spikes at the same time every day. And I'll show them to you here in a minute. So anyway, let's just jump into it. I'm also got some Coronal hole stuff and some filament releases on the sun. Active areas, it seems as though the sun is waking up. I mean, it really is. So we'll take a look at that too. Anyway, this is from Little Sister of the Earth. It says, they look like labor pains on a monitor printout. What she's talking about here is the Schumann tool that we look at. It very much does look like a labor pain printout. Like if anybody's ever had a child, at least within the past, 20 years probably, you would definitely know what that looks like. In the labor rooms and the birthing rooms and stuff, they got the monitors all hooked up, and it continuously prints this out. And what it's doing is it's tracking the contractions. And I'm saying all that so you understand what I think what she's saying here I agree with. The Earth's having labor pains, guys. Yeah. That's pretty much the way I look at it. So great comment, and I think that really kind of puts it in perspective for quite a few people. And but that is a different way to look at it than what some have in the past. But it is very legit. So great comment. This is Teresa Chase. Says, hi Mark, I'm dumb on weather, but I keep on hearing someone saying jet streams. What are they exactly, please? My body all pieces and my skin hurting all over. God bless you. No, God bless you back, Teresa. Well, first off, you're not dumb. Please don't call yourself dumb. Just don't do that. It's not a positive thing to do, and I get it. I do it myself sometimes to myself. So I get that, but just don't do that. You don't need to do that here. It's fine. Any question is not dumb anyway. Like we've all heard this before. The only dumb question is the one that's not asked, right? We don't get smarter unless we ask the right questions. But as far as to get to your question, what is the jet stream? Well, what it is it's the upper level wind currents that basically steer our weather. Okay, so why do they call them jet streams? Well, they call them jet streams because that's where they came from, is when the jets would fly in those streams, because it would reduce gas usage and all that kind of stuff. So obviously the jets go up to a certain level and a certain altitude, and that's where they fly, and that's one of the reasons why they go so high, is because of that. They want to catch that wind to give them a push. So but if you look at any of the maps that you see, you'll hear the Weather Channel say it a lot. Any weather report, I can't tell you the last time I've seen a weather report that they didn't at least use that word one time. But that is what the jet stream is. If you look at it compared to the northern to the southern hemisphere, if you look at a global map or tool or whatever, you're going to see that they are moving very similar but opposite directions. It's kind of crazy. But there's reasons for that. I'm not going to get into that right now. But as far as jet stream, that's what a jet stream is. It's essentially the steering currents for our weather systems. Low pressure, high pressures sit. Low pressures right along the jet stream up and over. Most of us have seen that. I'm sure you probably know what I'm talking about now after explaining that. So this one is from Cabana Light. It says, thanks Blue for the updates. Always interesting. The comments are great too. Thinking and curious people gather here. And that's right on the head right there. Thank you so much for that comment, because I've been saying this for a while. I get a lot of good questions here, guys, and I'm going to start showing them, which is why I'm doing this. I want you guys to know that I do read your comments, and this is one of the ways that I can show you that, hey, I'm paying attention. I just can't, respond to all of them. It's just too many. So I'm going to try to do it the best I can. But I do agree with this. This is something that I've noticed, especially, I don't know, past 6 months. It just seems like we've all gathered here and we can talk. And like I said before, some of the questions asked, I don't really even have to answer because the other subscribers will pipe in and answer that question for me. And I think it's great. So let's continue to do that. So anyway, thanks, Commander. All right, guys, this is the most updated Schumann tool as I'm making this video. As you can see, another spike. At what time? Look, guys, I mean, they're all happening at the same exact time, or at least really close to it. And something else I want to I'll point out here in just a second when I show you these next captures. So what I did was, it's 6 days in a row now, guys. 6:26. Just pay attention to up here too, or down here, whichever one you want to look at. It's really close to the same time every day. 6:27. 6:28. And it's really easy to follow it if you just look up here at the date, because the spike's starting right there on the tool. So 6:29 and 6:30, and then today 7:1. Guys, we can't make this stuff up. This is something that, my gosh, I mean, 6 days in a row spiking at the same time. After 3 to 4 days of almost dead silence, or not really seeing a whole lot here on this tool, and then these spikes start happening at the same time every day. So yes, this is something we need to look at. We need to pay more attention to this, because this is pointing us in a direction, and I don't know what direction that is yet. It's for us to figure out, but this is a clue to that. I mean, it has to be, because it's happening at the same time. That is, in my opinion, like I said before, multiple times, I have a hard time thinking that that's a natural thing. Okay, like I said before, unless it has something to do with what direction we're facing, as far as either out to space or facing the sun. Unless it has something to do with that, then I don't see how this couldn't be anything but intelligently done. Okay, so that's what I'm trying to say here. So, I mean, look at that. Okay, it's 6 days in a row right now. And I went back and looked at the 25th. It's kind of even there then. I just didn't include it because it wasn't real strong. But something else I want to point out. If you look at this, if you look at the Hurt levels here, see where they're all stopping? They're also all stopping roughly about the same place. Okay? The more intense ones, the ones that last a little bit longer, seem to be stopping right along there, this line here. Okay, that's one of the smaller ones. That's something else I've noticed here too, guys, is when we get the smaller signatures, look at the shape of them. Okay, they're very similar. Okay, the only one that looks like it might not be part of that is this one over here, because it's such a straight line. And none of these other ones even make it off of the Hurt level chart here. I think it goes up to 40 on this tool. Okay, so I mean, that's just another clue to say, hey, this came from the same source. It just did. I don't know how else to say it. And we have to pay attention to this, because the more and more, if this continues, man, I mean, we better be ready for something, because that right there, I mean, yeah. So if you guys are experiencing ringing in your ears, and I've said this all before, okay, guys, during especially these bigger spikes, these more intense ones that stick around for a minute, if you guys are experiencing that, this could be the reason for that, okay? Or it could not be. It could be you could have a health issue. Don't ever forget that, okay? This isn't the answer to everything, okay? as far as how we're feeling. It's just part of the puzzle. And we have to keep in mind that there's other things that affect us too, not just this. But this is a big thing. So, and that's why we talk about it here. So, given the fact these are happening the same time every day, they're roughly going up to about the same hurt level and stopping, and they're not really going any further up. And they're roughly lasting about the same time frame. I have no other way to conclude that this is something being done intelligently. So I'll leave it at that. And, you know, guys, we'll watch it again tomorrow. I could probably even watch it here in a few hours, and I'll be able to tell you if we're having another spike about that time, because if you look, you'll see like white lines just start to appear right on the edge of the screen, right where the data is ending for that day. You'll see a white signature start showing up, and, you know, you can pretty much say, hey, listen, there's the start of another spike. Alright guys, here's a geo-electric field model. I'm going to show you guys this probably every video too, because I think it's interesting, and it is kind of like right now what's happening. What this is showing you is space weather's effect on our electrical grid. Basically, it's kind of like a warning saying, hey, listen, you're starting to see activity here. You might pay attention to brownouts or other electrical issues. I can tell you from looking at this a couple hours ago that this was actually fluctuating a lot more. I was seeing a lot more brightness happening. It's kind of going, almost looked like a wave of such. But, you know, we can't look at archive data of this. They don't have it. They won't let us access it. I know they're keeping it, but we don't have access to it. I wish we did, but we don't. You know, because then we could go back and analyze that stuff. So the only time we catch stuff on here is if it happens to be there within that 2-hour time frame when we click on this. And, you know, chances are, if I was to talk to a lot of other people that look at this, you know, if they were recording like I do, we could probably put together a whole day worth of it, at least, you know, consistently. But that would take so much work, and I really ain't seeing a whole lot here other than just a couple little, you know, glitches. Oh, I'm not even gonna call them glitches. Just little pulses coming from, you know, space weather. So, you know, but yeah, so right there, it's pretty normal conditions. Okay, got you over at NOAA Space Weather Prediction Center. And something you're going to notice, remember yesterday here on the X-ray flux, I was showing you guys, when I did my video, we were starting to see this uptick. Well, look what happened. It kind of fell back off. And what happened was that those active areas that look like they could be turning into sunspots, they're having the one at least that's emerging right now is having a hard time getting to sunspot status. Okay, it may not ever make it. We'll just have to wait and see. But there's actually one behind it that I want to show you guys here in a minute. And there's also one on the upper eastern limb of the sun too. Now keep in mind, when I say eastern limb of the sun, it's backwards as if you would think here. Okay, so if this was the sun, east would actually be over here. West is over here. Okay, north and south is the same, but east and west are flipped. Okay, that's how they do it. That's how, and there's reasons behind that, but that's how they talk about the sun. It's just reversed from what we would think of if we were looking at a globe or a map for ourselves, trying to make it to our destination, so-called. But when we're talking about the sun, if you hear somebody say like the eastern limb, it's actually opposite of what you think it would be. So, just thought I'd throw that in there. But this is interesting right here, okay? Geomagnetic activity. Now, granted, this is nothing that big, okay? But what is significant here, my guess is we may be experiencing one of those coronal holes, the solar wind and the density. We could be getting a coronal hole stream coming at us here. We'll have to see how long this lasts. But what's interesting about it is that, you know, it was kind of staying low, and then it jumped up even more rather quickly. Okay, it didn't jump up like the very next capture or the very next data release point here, but it did jump up within 2 all the way up to 3 when it was on 0. That is significant. That's jumps up that far that quick. We got to pay attention, because the next one we see could be up here or up here. You never know. You just don't. If we get a solar flare or something, you'll see that thing just jacked right up, or a CME. But yeah, so here's the sun, guys. Listen, this is the sunspot I was talking about before. It's having a hard time really getting to sunspot status. It may never, but it is from solar cycle 25 if it actually gets designated as a sunspot. The polarity is the right way, okay? So it would tell us what sun cycle it's from, either from the one we're coming out of or the one we're going into. 24 to 25. That's what we're talking about. But look at this thing behind it. Okay? That almost looks more impressive. Because you remember me talking about the parallax effect in the last video, right? Well, if you apply that right here, because if you're just looking at this straight on, these spots look about the same size, right? Well, if you apply the parallax effect, this one over here is actually bigger than this one. Okay? Because they look smaller towards the edge of the sphere, right? So, we got to keep our eye on that one. This one too, okay? This one here was releasing filaments, and I'll show it to you here in a few minutes. But here's the coronal holes, okay? Now, what I want you guys to pay attention to here, obviously, is the equator, and the Earth is here. We're still getting coronal holes continuously, like stopping and starting. In other words, they're passing in front of us, exiting, and then we're getting another smaller one right behind. It's like a series of small ones, is what I'm trying to say. Now you can see how the northern coronal hole is trying to stretch down. Okay? Now you can see the darker areas here. And again, I said yesterday, we've seen coronal holes stretch from the north to the south. Big, huge, gaping holes. But with everything, if you look at this, let me zoom in a little bit. If you look at this, the darker areas are right on the equator right now, except for all the way on the north and south pole, right? So that means we're going to continuously see uptick here, okay? Because the solar winds are going to keep coming. So that's what we got to pay attention to. So I just wanted to point that out. So if we go down here, we can look at these models. They're saying here on the Enlil model that well, yeah, there it goes. They're saying it doesn't look like hardly anything's going to go on, which very well could be. It's not really showing much of an uptick in anything. Wherever we're at right now, it looks like we're going to stay there for a few days. But I have a hard time with that. I don't really think that's going to happen. Hardly ever does. So we'll have to wait and see. Here's the ACE data. Okay. The orange is the density. And you've heard me talk about density. And in the yellow is the solar wind speed. Okay. You mainly heard me talking about, like, this is the sun, the earth. We're connected with IMF lines. Okay. Interplanetary magnetic field lines. That's what that is. The solar wind travels that line. Okay. And it's not wind, like I said before. It's charged particles moving along this line. So if you get a high dense one, it stays closer to the middle, thus giving us a big, more direct punch, right? And then the lighter density ones are out further, so it's not as direct, and it doesn't tend to have the effect on us geomagnetically that a higher dense impact would be. Okay. We can still get good activity by just solar wind speed itself, though, too. It can be very low density and have a very high wind speed, or high speed, I should say. And they measure that in kilometers per second. So I think it's, 400 kilometers per second is roughly like 1,000,000 miles per hour. So keep that in mind when you're when you're looking at these graphs. Okay. Here's the aurora forecast. We're not going to look at that too much because we're really just not experiencing hardly anything right there right now. If we do start getting some solar weather, it's going to cause us to see auroras. I'll take you guys here and show you that. Okay, guys, I got you over at SDO. And what I want to show you is a couple releases here, okay? Watch this up here. This one here is pretty impressive. It's a filament release, and you see that? Basically, it's a CME, okay? We're just going to call it that for lack of a better word here. But what you're seeing, basically, it's a filament like inside a light bulb, okay? You know, you got your light bulb, right? And, you know, I know it's a crappy picture, but what makes the light is where this comes up and there's a filament between these two. It's the restriction there that causes that light. Okay, that's a filament. When that busts, that's when your light bulb goes out. Now that's on an incandescent light bulb, not an LED. Okay, but I wanted to show you that because it does help explain what a filament. It's the same thing on the sun. I mean, they'll release off. Okay, they're filaments. The particles travel on those things. Okay, so as you're seeing here, I'll zoom in here a little bit more. We'll see it. See that thing? Okay, that did leave the sun. It went off the backside pretty much. It's not coming at us, so don't think that that's going on. But we also had one kind of pop off down here, and I'm going to take you over and show you the 304 here in a minute because you can see it a little bit better. It's hard to see it when they're right on the face of the sun because the sun's the background, not the blackness of space. So it's kind of hard to see things. That's why we catch things a lot more easy on the limbs because the background of space, the blackness of it, is the background and allows us to see more. Okay? Now here's that sunspot we were talking about here. Also, you're seeing that jumping around, guys. Don't think nothing about that, okay? What that is that's a calibration roll, okay? They have to calibrate these things to make sure that they're, you know, staying on course, pretty much. Make sure everything's fine. I'm not sure exactly how the calibration runs itself, but you can see that if we were to stop that, it would be completely blocked off in like a hexagon shape, kind of. Okay? It's very rigid. See, we'll watch it right here. Watch. It's going to come up here. It does look like crazy stuff's happening, but all that is it actually is. It's a scheduled thing. You seeing that? Okay? They have to do that to make sure they're in the right spot. That's something we see. We see it do that all the time. Now, sometimes we do see these things shake or really get hit sometimes by solar wind, and it'll move it. It'll shake it, and you can see it in some of the captures that we show, and I've talked about that before. But down here, guys, obviously you're going to see that sunspot kind of try to emerge. It's already starting to right here. Watch how it goes through. See how quickly that came up to really good brightness, and you can see it start to get pretty healthy. I'm not sure if it's actually going to make it to sunspot status, but it very well could. Plus, there's one right behind it I was just showing you guys a few minutes ago. Okay, any of those at any time can blow a flare or a CME. That's why we pay attention to these things, guys. It could happen at any time. You don't even have to have a sunspot to have that activity. It can happen on a completely dead spot on the sun. If the sun decides it wants to blow something out, it's going to. In other words, if it thinks it might have ate some beans during the day, it's going to fart on you, I guess. I don't know. Sorry if that offended anybody, but you know, it is what it is. Okay, guys, here's the 304. All right. What you're going to see here on this one, if you look at the limbs of the sun, like I was just talking about, the edges, you're seeing a lot of filament activity. Okay. And that's going to continue. I see us to continually move up in activity. It's not going to slow down at anytime soon. Okay, it's going to vary, obviously, but we are seeing that. Now let's go up here and we'll watch this filament release up here. When we're looking for filaments, this is a really good one to go to. The 304 sees the filaments really well. And what the 304 is, it's the angstrom of light you're looking at. Okay, and it sees different gases basically because different gases show up in different parts of the light spectrum that we can't see with our eyes. Right? That's why they call it extreme ultraviolet. Okay? So they put these filters on there so we can see this stuff. And this is the 304 filter. But you can watch this filament. It'll release out. You'll see it. See how it did that? Now watch, here comes the other one. That's the one we seen on the 171. Okay, and you've seen it leave the sun. Now sometimes, I've shown this before, the filament will go out and then it gets recaptured by the sun. So if it does that, that's not a CME. Okay, because the sun recaptures it. It's not going to hurt anybody. It's not going to do anything really, except for maybe give us some X-ray or something, maybe. With the weight, sometimes you don't always even see that. Now, if we look down here, I'm going to kind of zoom out a little bit. You're going to see like a dark shadow down in here. Okay, so let me zoom in down here, and we'll let that run through a couple times. And what that is it's another filament release. It shows up as a dark shadow. Right about, see it there? You see that? Okay, it kind of it's right in that area. Alright, so I'm going to zoom in again, and we'll try to catch it here a little bit. I know it's hard to see sometimes, especially with the sun being in the background. I get that. But I want you guys to see that, because this one here, there it went. See that? See how it just shot off? When we go look at stereo, if we were to go over and look at stereo A, it looks like it does show this one, and it's blowing off the backside. Okay, so don't think it's coming at us. And this one here, actually, I'm not sure exactly what direction that blew off. I don't think it was coming at us too much, because the CME tracker didn't even change. So if it is coming at us, they don't expect it to be much of anything. So we're not really going to be concerned about that too much. But it is another, place to say, hey, sun's waking up, guys. Pay attention. Okay? That's what I would say to that. Okay, now this is the 211. I show you guys this every once in a while, but this one seems to show a more, it shows the corona holes better. It shows the thinner spots in the corona a lot better, okay? Because as you can see, you see a lot more black on here, right? So that's just telling you that it is opening up, and it is most definitely, we got to be paying attention to these corona holes. Guys, corona holes can really jack us up sometimes. Okay, it can give us good auroras. That's a good positive thing. But it can also give us some pretty good geomagnetic activity that can be problemsome just from here or there. Doesn't have to be something every time, but it does give us issues sometimes. So that's what I would say to that. But just keep in mind, these things are rotating through. Again, the equator, Earth's kind of right here. So anything that rotates that direction, guys, yeah, it's going to give us some, solar wind. That's just what happens. So yeah. But, yeah, guys, I'm going to go ahead and end the video here. I'll come back with you tomorrow. I just want to make sure that you guys understand this corona hole thing, okay? Because I do think that this is a subject that kind of gets lost, because people assume that everybody knows what that is and what it can do. I think it's good for people to have either a refresher on that, or people that don't know what it is. It's not a very hard thing to explain. It takes a couple minutes, but it's worth it if somebody can understand what we're actually looking at here. So we just got to pay attention. Is there anything we can do about any of that? Absolutely not. Okay, but let me leave you with this. Okay, the Schumann, 6 days in a row. Most likely, if the pattern continues, it's going to be a 7. It could turn into an 8. Who knows? We've seen patterns like that before, but I don't think that I've ever seen it happen 6 or even 7 days in a row like this. Okay? If we had a spike and it lasted, 15, 20 hours or something, and we have before, I've shown that before too. But these spikes are roughly lasting about the same time frame. They're starting at the same time, and they're going up to roughly about the same hertz level. It's not a coincidence, guys. Something's going on there. So we're going to have to just pay attention to that. So anyway, guys, God bless. Yeshua saves, and you can drink this Kool-Aid.